Hello class. Well, as I said in lecture on Friday and on Monday and also in an email, I'm actually in Ottawa right now at the Canadian Agricultural Policy Conference. And so rather than canceling class, what I thought we could do is actually go through the examples that I would otherwise work through in class through one of these online videos. So just as a recap from the video that you would have seen for the first video that you would have seen for investment analysis, what we're talking about is how to invest money. Now, there's all sorts of applications of this, ranging from making capital budgeting decisions for an enterprise to your own personal life and trying to think about retirement planning. And what's important in this is the time value of money. And recall the idea behind the time value of money is that a dollar today isn't necessarily worth a dollar 1 year, 2 year, 3 years into the future. And there's a number of different factors that cause money to have a time value. And so we need to take account of that to make sure that when we're comparing a dollar today to some future amount, that we're actually comparing apples to apples, not apples to oranges. Now, in the previous video that dealt with the conceptual ideas that we're looking at, we talked about finding future values, and this is known as compounding. And the idea here is how much will a given amount of money be worth at some point in the future. And there's a couple of different ways to do that, but one of them, and the most useful way or convenient way, is to use the future value formula. So what I want to do in this video is actually work through a couple of examples. Some of them are a bit simple, some of them are a little involved, but it gives you an idea of how you go through the mechanics of doing this. So it's kind of nuts and boltsy, but it's also really important. And as I said before, this goes beyond dealing with investment analysis and capital budgeting for a business enterprise and has a lot of relevance to things like personal finance. So you should really work hard at making sure to understand these concepts because they could be useful in your life later on. We're going to start by looking at a simple example. And we're going to use an example of something that's known as a LIRA. That is a locked-in retirement account. And the idea behind a LIRA is that you give your money to some financial institution and they're going to keep it for a fixed amount of time. Your money is locked in. You're not allowed to access it. Now, some institutions allow you to access it for a fee, others don't. I actually have a LIRA right now that I'm not allowed to actually access until I retire from wherever I'm working. The analytics behind LIRAs are relatively simple, and let's take a look at this using an example. Let's suppose that you had $9,200 to invest right now. So the present value is $9,200. And you're looking around at different financial institutions and you see one of them's offering a locked-in retirement account at 6% interest. And that's 6% interest per year. And let's suppose that you're 22 years from retirement. What you might want to know is, well, given the future value or the present value and the interest rate, how much would that $92,000 or $9,200 be worth at some point in the future, in particular 22 years from now when I retire, when you retire? What's it worth when you retire is a question that you should be asking. Well, to calculate that, we can use the future value formula. And remember that the future value formula is FV, that's this little bit right here, and that's going to equal the present value, that's the amount of money that you have right now, times a compounding factor. And in this case, the compounding factor is 1 plus the interest rate, all raised to the power n, where n is the number of years that you're going to have that investment. So all we do is we substitute the $9,200 into present value. We substitute the 6% interest in for I, not as a percent but as a fraction, and then we substitute the 22 into n for the number of time periods. And when we do that, we end up with this equation right here that I'm circling with the mouse. And if you work through the calculations, you'll see that it's going to end up being $9,200 times the compound factor of 3.6035. And if you work through the math, that's a little over $33,150. And so what's happened is because every year you get 6% interest on the principal, on what you've accumulated up to date, this $9,200, I won't say quickly, but eventually becomes over $33,000. And so this is the kind of idea that you might be interested in doing if, for instance, you have a LIRA and you want to know, okay, is that going to be a large sum of money when I retire, and will it be enough money when I retire? When my wife and I go through our financial planning on a fairly regular basis, these are the kinds of things that we actually work through, saying, all right, we have X amount of money now, what's that going to be worth in the future, and is that going to be enough to retire? Now this is a simple example. It's a very simple example. What I want to do now is turn to an example that's a little more complicated, but it illustrates again how we can use the future value equation. And we're going to do this for an agricultural example. And it's a bit of a contrived example, but keeping this simple helps you understand and see where things are actually happening. So let's think of an example. And so as the screen says, suppose a farmer is deciding to continue to grow a crop that they're currently growing, or they could choose to grow a new crop. The current crop returns $160 per acre on an annual basis. The new crop has a life of 5 years, at the end of which the farmer could either shift back to the current crop or replant the new one. Although the returns on the new crop total over the 5 years are higher, they're also distributed unevenly. So the producer has to make a decision about which crop should they grow. Now remember, in the video that you would have watched leading into these examples, we talked about the notion of opportunity cost. And this is just the return that you think you could get if you'd invested those monies elsewhere. In this particular example, the opportunity cost, or if you want to think about it, the interest rate that we're going to use in future value calculations, is simply 10% per annum, or 10% per year. Now the next slide is going to show the pattern of the returns for this example for the new crop and also for the current crop that they're growing. And what we want to get at is what's the future value at the end of 5 years. So this is the future value, or not the future value table, but the value of the perennial crop in year 1, 2, 3, 4, and 5, and the value of the current crop on a per acre basis in years 1 through 5. And if we add up the cash flow over the 5-year planning horizon, what we see is that for the new perennial crop, you would expect to make $825 per acre, but for the current crop, you only expect to make $800 per acre. Part of the issue is that the pattern or the flow of money from that new perennial crop is relatively uneven. In the first year, you actually lose money, and then in subsequent years, you earn a larger amount of money. What we want to be careful of is that a dollar in year 1 isn't equal to a dollar in year 5. And so what we need to do is we need to calculate the future value of each year's crop. So what I would do, for instance, is calculate the future value of $160 in year 1 in year $5, and $160 of year 2's crop in year's $5, and the same thing for the perennial crop. And the reason why we do that is that it gives us a common basis of comparison. We then know that all these dollar amounts are being compared on the same future value basis, rather than their worth in year 1 and their worth in year 2 and their worth in year 3, 4, and 5, while ignoring the time value of money. Now, the slides I'm going to go through should mimic or reflect a table that is given in your notes on page 4. And the idea here is that I want you to fill in some of the values as we go along. I've made sure to leave some space at the bottom of that page for you to write any notes. And so if you get stuck or need to stop the video to make notes, please be sure to do so, because it's a good opportunity to make sure that you're clear on the matter. So this is the table that you see in your notes, and up at the top here I've got the future value equation, and this is just a reminder to us of what we're going to try to calculate. So we know the present value, that is, we know the value of the return to the new crop in each year. So $75 is the present value of the crop in year 2, $150 is the present value of the crop in year 3, etc., etc. And we know the same thing for the current crop. What we want to do is calculate the future value of each year's cash flow from each crop after 5 years. Now I've picked 5 years as an arbitrary number. We could pick 100, we could pick 3, we could pick 29. It really doesn't matter. I'm just trying to illustrate the point with something that's got a reasonable degree of length to it. But in order to calculate the future value of the cash flow coming from each crop in each year, we actually need to know the compounding factor. This is a piece of information that's critically important to this. And remember that we're assuming that there's a 10% opportunity cost. And so what this means is that I, in the present value equation, the interest rate, is simply going to be equal to 0.1. The trick with this example is that the value of n is going to change as we move through time. So let's see how that's going to happen. And let's ask ourselves, all right, if I want to calculate the future value of crops in year 5, what I need to do is calculate the compounding factor that would take me from year 1 to year 2 to year 3 to year 4 to year 5. So for year 1, the compounding factor is going to be equal to 1.464. And I got that because I know that at the end of year one, there's 4 more years until I reach the end of year 5. So that means the number of time periods over which that compounding factor is calculated is raised to the power 4. And I've shown that with the example, or this equation, where I've taken the compounding factor in general terms, I've substituted in 0.1 for the 10% interest rate, and I've substituted in 4 for the number of time periods. And again, it's 4 because we're going from the end of year 1 to the end of year 5. So it's going from 1 to 2, then another year, then another year, then another year. So we've got 4 time periods between when we realize the cash flow at the end of year 1 and we want to calculate its future value at the end of year 5. I can go through the same kinds of calculations, and so in year 2 the compounding factor is going to be different because now I'm 1 year closer to the end of year 5. And so what I have to do is adjust the number of time periods in the compound factor to reflect that there's now fewer periods over which that money would be earning compounded interest. In this case, what I've done is I've simply changed the number of years in the present, or in the compound factor, from 4 to 3. And so if you actually stop and do the calculation, you should see that that compounding factor going from the end of year 2 to the end of year 5 is 1.331. And again, I can go through the same kinds of exercises for the compound factor for the cash flow that I have at the end of year 3. That's just going to be 1.1 raised to the power 2. It's raised to the power 2 because I'm only going to be earning interest on the cash flow from year 3 for 2 more years. That is till the end of year 5. So I'm going from years 3 to 4 and then 4 to 5. And I can go through and calculate all of these for the subsequent years. So the compound factor for year 4 is only going to be 1.1, and that just reflects the fact that I'm going to be earning interest for only 1 year. And so my compound factor calculation is 1.1 raised to the power 1. The compound factor for year 5 is only going to be 1, and the reason why it's 1 is that we're earning this $300 at the end of year 5, and so there's no time period over which I'm going to be compounding. And so all the present value calculation is equal to is 1.1 raised to the power 0. Okay, so we've got these compounding factors, and what you should see is that they start large and then they get smaller, and that's just a reflection of the fact that if I earn money in year 1 and I'm going to earn compound interest, it's going to be worth a lot more in the future than it is today. What I then do with these compound factors is use them to calculate the future value associated with the new crop and also the current crop. And so to do that, I just apply in each year my present or my future value equation. So the new crop future value after 5 years from year 1 is simply going to be the compound factor times minus 100. And if I do that for all the years, then what I will see is this flow of cash stated in year 5 dollar values. And so for instance, 99.83 is simply the future value of the $75 I earned in year 2 stated in year 5 dollars. Likewise for the 181.50 future value for cash flow in year 3, that's simply the value of it at the end of the value of the $150 I earned at the end of year 3, but stated at the in year 5 dollars. And so these calculations are dead simple. It's simply the compound factor times the present value term to get these columns. And then at the bottom here, what I've done is I've just added up so that we have a sense of, okay, how much is that worth overall? We can do the same thing for calculating the current crop future value after 5 years. And again, for each year, it's just a question of multiplying the compounding factor times the present value of that crop in the respective years. And if we do that, we're going to end up with this string of numbers. And then if we add all of those up, what we see is, okay, now the total value from the current crop future value after 5 years is $976.80, but for the new crop it's $874.93. So there's a couple things that are important here. So first of all, notice that the future value, the sum of the future values is larger than the sum of the present values. And that's because the future value calculations take account of the time value of money. The other thing that's important is that if we had ignored the time value of money and made a decision based only on the sum of the present values, then what we would have done is chosen to put in that new crop, because it would have yielded a total cash flow of $825, while the current crop only gave us $800. But now, after we take account of the time value of money, and given the uneven pattern of the cash flows for this new crop, what we see is that the new crop actually gives us less money in future value terms than the current crop. And what we would do is we would stick with the current crop, because that's going to give us $100 more per acre. So that's a pretty complicated example. We're going to come back and illustrate it again, but what I really want to impress upon you is the importance of trying to think about how to use this equation to calculate the future value in some sort of a time period in the future. Now, what's also important here is that when I've been dealing with these examples, and is measured in years, but it doesn't have to be. Sometimes we have compounding periods that are measured in months, in weeks, occasionally days. And when that happens, we have to make some adjustments, not necessarily to the equation, but how we calculate the interest rate that we're going to use and the number of periods that we're going to use. And so let's look at an example of that. So let's think about what the future value of $25,000 would be when it grows at a nominal annual interest rate of 11% per year, but that interest is compounded monthly, and it's compounded monthly for 2 years. Now, you might be tempted just to calculate the future value by applying the future value equation, where $25,000 is the present value, 11% is the interest rate, and n is equal to 2. But that would be wrong. And the reason why it would be wrong is that what we know is that for this example, interest is compounded monthly. It's not compounded annually. So what we have to do to account for that is we have to adjust the interest rate that we're using in that present value or the future value calculation to a monthly basis, and also change the number of time periods from years to months. And if I do that and I substitute the relevant terms into the future value equations, what I have is the present value of my investment, that's $25,000, times 1 plus 0.11 divided by 12. And so this 0.11 divided by 12 is simply the 11% annual interest rate divided by 12. That is, it's putting it into monthly terms. So now my interest rate is measured on a monthly basis, and the number of time periods that it's being compounded over is not 2 years, but rather it's 2 times 12 to reflect the fact that there's going to be 24 months during this 2-year time period. And when I calculate what the future value is, it's $31,120.70. So you need to pay attention to the circumstances about how interest is compounded in these situations. It's not unusual for interest to be compounded monthly. Certainly when you're dealing with mortgages, interest is compounded monthly, and sometimes it's compounded bi-weekly or even weekly. And so you need to make the adjustments to not only the interest rate that you're using, but also the number of time periods. All right, now let's go through one final example. And again, this is a bit of a simple example, but it shows you how you can proceed if you've got different interest rates during different time periods. And this isn't uncommon. Some interest rates for mortgages are structured like this. And so let's consider a portfolio manager. Now, just so you know, a portfolio manager is someone who manages other people's money. So if you invest in mutual funds, for instance, those mutual funds are a portfolio of individual stocks, and the manager is responsible for making sure that there's adequate returns. So let's suppose that a portfolio manager is considering investing $500,000 in a guaranteed investment certificate. Now, GICs pay an annual interest rate that will be known ahead of time, and let's suppose that annual interest rate is 5.7% and that the investment would be for 4 years. Then, after 4 years, the manager will reinvest the proceeds for 3 more years and expects that for that 3-year period, the annual interest rate would be 7.2%. What you have to ask yourself is, what's the future value of this investment after the total 7-year time period? Well, to calculate that, let's break this up into 2 steps. Let's calculate the future value using that first interest rate of 5.7% in 4 years, and then the future value using the interest rate of 7.2% over the last 3 years. And when we do this, all we have to do is plug in the right numbers in our future value equation. So here I'm calling this future value 1 to represent that this is the first step. And that's simply going to be the present value of the amount of money I have to invest times the compound factor. Now if I substitute in the right interest rate and the right year into that compound factor and the right present value, I'm going to end up with the future value of that $500,000 at the end of that initial 4-year time period being a little bit under $625,000. So this is what I've got at the end of 4 years, and then the portfolio manager could reinvest it at a higher interest rate but for a lower time period. So what we'd want to do is figure out, well, what's that then going to be worth? And so in the second stage, the way to think about it is that this future value at the end of that first step becomes the present value in the calculation for the future value at the end of the second step. And so here I've rewritten the future value equation by saying the future value at the end of the second step is simply equal to the future value at the end of the first step times the appropriate compound factor. And so what we would do is, instead of substituting in $500,000 into the future value 1, we would substitute in the $624,122.66 into that, and then we would substitute in the appropriate interest rate and number of time periods to reflect what we know or what we think we can get in that second period. And if we do that calculation, what we end up with is 1.072 raised to the power of 3 is the compound factor. Where again, remember that 7.2% interest is earned in that second, or in the last 3 years of this investment horizon. And if we work through the calculation, what we see is that at the end of 7 years, that initial $500,000 is now worth $768,872. Okay, so there's a lot that we covered today. We're gonna call it a day at this point. What you should do going forward is watch the second set of theory videos on investment analysis, and I'll make sure to label those separately. And then there's another video to illustrate the examples for that set of lectures. So I hope you've understood this clearly. Please feel free to ask me any questions that might have come to mind in the course of looking at the video. And by all means, feel free to rewind and start again if you think you need to cover more ground.